Well, the point, what we've been building up to, this is it. This is the point. So we can solve any trig function. Well, of these special angles at least. And when they're not a special angle, you just plug the shit into a calculator. Then you round it and you get an answer. But we're going to look for exact values. So the exact value of trig functions. And I'm telling you, this is the game. This is the point. You can punch some calculators. You can punch this shit in, and you can get an answer. And you might be able to get through like this worksheet, and maybe some of your homework, and through the first exam, possibly just by using a calculator. Yeah, you might be able to do that. But you are cheating yourself horribly because you're going to have to think backwards soon. And you're going to kind of just have to know, and your calculator won't be able to spit out the answers. You're going to have to come up with the answers. So at the beginning, you're only cheating yourself. You're going to take what's going to be the most challenging part, even if you do understand this, and you're going to make it even more challenging by not knowing. You'd just be cutting out, like, I'm not going to learn addition and subtraction, but I'm just going to become a badass with multiplication and division. Yeah, sure. So let's play this game. So here's an exact value worksheet. There you go. And this is under worksheets and test prep. You can find this if you like. And shit, why even do it? Why even say you have a quiz? This is your quiz. It's quiz 2B. So you need to fill out this worksheet, and you're going to be able to find it in the same place you found quiz 2A. It's under worksheets and test prep. That's the module. And then you're going to want to go and find it as the PDF. It's called exact value of any trig function. That's going to be the worksheet I'm going to need you to turn in. Again, like I did in the last video, I'm going to do a few of the problems. I'll get you set up. We'll talk about it. This is something I would usually have you do in class in groups, just like with the reference angle. But since we're not in groups, you get to do it on your own, and you get to watch me do a couple of them. So without further ado, let's get into it. So here we be. Let's look at our first page. There's two of them. Second page gets a bit more challenging. But we're going to start using just kind of some steps to be able to solve anything. I'm just writing down my first quadrant over here. These values that I beg you to learn. I'm begging you. I mean, I am on my freaking knees. I'm not literally on my knees, but come on. Please, can you memorize, what is that, 5 numbers? 5 numbers? What is that? What is that? 1, 2, 3, 4, 5 numbers. And then no degrees and radians? Can you just do that? Can you memorize 5 numbers for me? All you bio majors out there, they're going to have to memorize hundreds of terms. Can you memorize 5 numbers for me? Just 5. Well, to do an exact value this way, there's some steps. So we want to find the exact value. Again, you write down a rounded ass decimal number. That is wrong. 0. No points. Nothing. I ignore. Unless it asks you to round, do not frickin' round. Now, the order may vary depending upon your style, is how you do this. After a while, you should be able to solve any one of these in your head. You don't even need a piece of paper. Some of them you might need to write down. Like I have some challenging ones at the end you might need to write down. But after a while, like there's none of these that our tutor, myself, I can solve all these in my head. Not because I'm smart or because I'm like a genius or anything. It's just because there's this little pattern and it's a game. And once you get good with the game, the stuff just starts to pop out. And this is where you want to be in calculus because you're going to be asked shit like this. If you go into a calc class, something like sine of 5 pi over 3, you're just going to have to know the answer to that. And when you're dealing with, say, a calculus test that's timed and it's 2 hours and there's like, you're barely going to make it, you don't want to have to sit there and like go through and think super hard about this. So I'm done babbling. I'm done. I promise. Let's go. I lie. I'll probably babble more. So we got these steps. First thing, just like with the reference angle worksheet, we want to first look and just see if it's coterminal to an angle. Right? If that shit's bigger than 360 or smaller than 0 degrees, like, dude, get it between 0 and 360 by adding 360. Or if it's smaller than 0 radians or bigger than 2 pi radians, add or subtract 2 pi radians and get that shit somewhere where we can look at it in just smaller terms. So like our first couple problems, part A does not apply. 5 pi over 3 is already between 0 and 2 pi. It's already there, so we don't need to use that. So part A is not necessary on all the problems. All right, so part B. And you don't have to write all the steps down. All I want to see is what the exact value of the function is. I'm just saying this is a roadmap to get you there. Now we're wanting to determine the reference angle, if any. So let's just go through with our first problem. We go, all right, for 5 pi over 3, what's our reference angle? And the reference angle is pi over 3. Go watch the last video. Go do your freaking worksheets. The reference angle is pi over 3. Now we just want to determine which... where was this? Where was this? 5 pi over 3. And now B and C, this step and this step, you can interchange them. You could do part C before you do part B. I think in my head, I actually do part C before I do part B. So there's no order here. You choose. So we just take 5 pi over 3 and we just try and figure out which freaking quadrant it's in. Like 5 pi over 3. It's like down here. It's in the 4th quadrant. Cool. So we know what quadrant it's in. We know its reference angle. Now, and the reason we do this is we just want to know the sign. ASTC. We'll be back. So now what we could say about this is sine positive or negative in the 4th quadrant? It's negative, correct? So we're going to say that this is equal to negative sine of our reference angle. We're going to get the same answer no matter whether we plug in sine of 5 pi over 3 or just looking at our reference angle. So sine of pi over 3, we're like, well, what's that? What the heck is that? Sine of pi over 3? We should get these memorized up. Sine of pi over 3 is the square root of 3 over 2. So when you pop in the angle pi over 3, you should get the square root of 3 over 2 for an answer of negative root 3 over 2. All right. Sine of any number, oops, don't use alpha. Don't use alpha. Any number times pi over 3 that doesn't reduce is either going to equal, it's positive or negative root 3 over 2. As long as that shit doesn't reduce, like 11 pi over 3. I don't know. I'd have to look at it. But I know since the reference angle is pi over 3, sine of anything with a reference angle of pi over 3 is either positive root 3 over 2 or negative root 3 over 2. Yeah, there it is. We go to cosine of 5 pi over 3. Let's go. I'll do this one with you. I'll do this one. Actually, no. Screw that. You figure it out. You got it. You can go. Let's look at cosine of 17 pi over 6. Let's look at this one here. Now, this is where we want to use part A. 17 pi over 6. Oops. 17 pi over 6 is larger than 2 pi. Huh? It's almost 3 pi. So what we want to do is we want to take it and we want to get it smaller than 2 pi. Well, we want to get a coterminal angle. So let's do this. We take 17 pi over 6 and we're like, well, since it's bigger than 2 pi, why don't we go and just subtract out 2 pi? But we need a common denominator, right? So I'm going to do this trick quite often. I'll show you this little trick. It's just with the 6's because we're going to put a 6 down below and we got to put a 6 up top and multiply, right? That's our 1 to create a common denominator. But what's 6 times 2? It's 12. So you get 12 pi over 6. And I use that trick and I don't really explain it very often, where I'll just write 12 pi over 6 as 2 pi. And that gives us a 5 pi over 6. So that was that part A. That was this from up above, where it says part A, determine if that angle is between 0 and 2 pi, or if it's not between 0 and 2 pi or 0 and 360, find a coterminal angle to make sure that shit is. Now we can go through and find out which quadrant the angle lies or what the reference angle is. So we can say, by the idea of coterminal angles, that cosine of 17 pi over 6 is the exact same thing as cosine of 5 pi over 6. Trig functions don't give a shit how many times you spin around in a circle. They only care where you end up pointing. All right, so you always want to get it between 0 and 2 pi or 0 and 360 degrees when trying to solve these problems. Let's go. So we got 5 pi over 6. Maybe we move to the next one and I ask you, what's the reference angle? And you're like, oh, radians aren't a big deal. Just pi over 6. No biggie, huh? We got a little pi over 6. So we're like, all right, cool. Now let's find out where 5 pi over 6 lies. 5 pi over 6 lies in the second quadrant. And the reason we do it is we want to play that game, ASTC, and figure out whether we're positive or negative in that quadrant. Because we get to here, just by knowing this, we can say that this is equal to cosine of pi over 6. Oops, no, we can't. We have this little question mark going, I don't know, maybe it's plus or minus. I got to figure out what the frickin' sign is. And we use that game of going, wait a second. Cosine is positive in the first quadrant and the fourth quadrant. That's where it's positive. It's negative in the second and the third quadrant because cosine goes with x's and x's are negative off to the left. So we go, oop, we can remove the question mark and go, it's negative. That's why we check the quadrant. Now we go through, we leave our negative, and then we evaluate what's cosine of pi over 6. I won't go back to the table. I'll leave that up to you. And that's the square root of 3 over 2. It's like it's these same freaking numbers are going to pop up over and over and over and over again. And over and over and over and over again. But if you start to memorize them, that's the point. I show them to you 1,000 freaking times, and then all of a sudden they get stuck in your head, and then you can go to your calculus class and get patted on the head like I did once I learned these freaking values. Sweet. Mess around with degrees. I know you love them, huh? Degrees suck with this game. Because you have to go and actually do some work to figure out what the reference angle is. Look, I can go to this one here. 91 pi over 2. And I'm like, do you know what the reference angle is? Pi over 2. All right, moving on. 13 pi over 6. Negative. Do you know what the reference angle is? Pi over 6. Pi over 4. Reference angle. Huh? Pi over 3. Reference angle? I don't want to tell you. You figure it out. It's actually very simple. Reference angle? I have no freaking clue. I just don't have any idea. I have to do work. And there's a lot going on there. It's probably 30, 45, or 60. I just don't know which. Okay. One more. And let's do one with a cosecant. Let's go into number 8. And let's get this thing done before 15 minutes. I know this one goes very long. Now, cosecant, that's chill. I'm not going to stress about the fact of cosecant. What I know is that this is equal to 1 over sine of 15 pi over 6. So what I'm going to do is I'm actually going to just go aside, and I'm going to solve this. I don't want to spend a bunch of time, energy, thought, logic, anything on cosecant. I just know I'm going to go take this, solve the way we're supposed to, and then I'm going to take my answer and I'll flip it over. All right. Now, what's the reference angle on this? Is it this? Is it just pi over 6? It's not pi over 6. It's not pi over 6 because 15 and 6, they're both divisible by 3. So this is actually 5 pi over 2. It's the same thing as 5 pi over 2. So this is sine of 5 pi over 2. And now we can finally start to begin our game. Well, we're like 5 pi over 2, that shit's bigger than 2 pi. Therefore, we need to subtract out 2 pi, which is 4 pi over 2, which is equal to pi over 2. So again, this is an actual equal sign. We're good. We're good. We don't have to do shit. Oh, pi over 2. That's already between 0 and pi over 2. We can just state the answer. What's sine of pi over 2? 1. But that's not what we were looking for, dude. We were looking for cosecant, huh? So let's go plug that number in, this 1 from here. Let's plug it in and see what we get. And we get 1 over, and that was 1, which tells us the answer is 1. There it is. Whoo, doggy. Huh? Fun shit. Hey, with these negative angles down here, the ones I'm not explaining, these negative angles, you're going to add 2 pi's. Not take them away, but you're going to add them. Get that shit between 0 and 2 pi. And then start playing your reference angle game. Don't deal with those frickin' negatives. Don't deal with the frickin' negatives. So, all right. I will see you in the next one. Have fun with 13 and 14. See ya.